Welcome to the fifth session of the third module. Continuously in the previous successive sessions from first session to the fourth session of the third module, we have discussed about the IC engines and its classifications, what are these IC engines and different types of IC engines, and then we have also discussed the two-stroke petrol engine and four-stroke petrol engine, and then we also discussed the principle of working of a four-stroke diesel engines also. And all these engines works in their own way with the principle of working. And later we have also discussed the types or the performance parameters like indicated, brake power, all those things. And then we have also discussed actually we are just left out with only one topic in the IC engines. It is the differences between four-stroke and two-stroke engines and the difference between a petrol and diesel engines. Now when you have understood the basic concept of working of a petrol engine or a diesel engine, then definitely no need to remember it. Automatically you can make out as much as points you just want it. Now before this is I always follow whenever I just ask you to differentiate between a petrol engine and a diesel engine, at least one sketch drawing. This itself will give you a clear confidence of listing out different differences between a petrol and diesel engines. Now as sketch itself shows, in the first figure it is a four-stroke petrol engine, wherein which there is a spark plug, there is an inlet valve in which what is happening is the petrol and air mixture is entering into the inlet valve, and in the exhaust valve as usual the exhaust gas goes off. Now what difference, what you can make it out with the sketch itself here is, instead of in the place of spark plug we have got a fuel injector in the diesel engine, and in the inlet valve during the suction stroke what is happening is, instead of fuel and air mixture we are getting it only the air. Is it clear? Now here we can also make one more difference, is that the charge is nothing but the combination of petrol and air in the petrol engine, whereas here the charge is only the fresh air. Is that clear? That is one major difference. And then when I was talking about the petrol and air mixture, the compression ratio here is very less. It varies from 6:1 to 10:1. Whereas here in the compression ratio of a diesel engine varies from 16:1 to the 24:1. So its capacity is more. Is it clear? So similarly, when I say a petrol and air mixture is entering into the engine cylinder, then who is mixing it? Who is mixing the engine's petrol and air mixture? It is nothing but a carburetor. A carburetor is the one which is mixing this petrol and air mixture with a proper air fuel ratio, that is 14.7 air fuel ratio for this and 14.5 for the diesel diesel engine air fuel ratio. Now here what happens? Because the petrol and air is mixing, we need a carburetor. Do we need a carburetor here? It is just an air. Okay, since it is only, once again I can also make a point with this addition, since only air is coming, the size of air filter will be bigger, whereas here the filter size is less. And then I have also made one more point, the compression ratio in the petrol engine is less, whereas the compression ratio in the diesel engine is more. When I say it is more compression ratio, then the size required for the engine for a diesel engine is more, whereas the size for a petrol engine is less. Okay, when the size is different, then the bulkiness of the diesel engine is more compared to the bulkiness of the petrol engine. When I say it is a bulkiness, the cost of the diesel engine is more when related to the cost of the petrol engine. And then whenever I say it is a compression ratio is different, then obviously we can also say the maintenance of a diesel engine is more. Maintenance cost whereas the maintenance cost of the petrol engine is less. So these are all the points that you can just remember by looking into the figure itself. It's okay. Some other points apart from basic one. The petrol engine works basically on the principle of Otto cycle, whereas the diesel engine basically works on the basic principle of diesel cycle. It is a basic principle. Is it clear? Now in the petrol engine, the heat addition takes place at constant volume process, whereas in the diesel engine, the heat addition takes place at a constant pressure process. The air and petrol are mixed in the carburetor and before they enter into the engine cylinder through the inlet valve. In the diesel engine, the fuel is fed into the cylinder by a fuel injector and is mixed with air inside the cylinder. Is that clear? In the petrol engine, what happens? The petrol engine compresses the mixture of petrol and air, which is ignited by the spark plug or an electric plug. In the diesel engine, what happens? It compresses only the charge of air, and ignition is done by the heat of compression. So only it is called as a compression ignition, and this is called as an SI. This is a spark ignition. Petrol engines are also called as an SI engine. It is spark ignition. Whereas here, the diesel engines are also called as compression ignition. That is, in the short form, they are called as CI engines. Here the compression ratio is very low, around 8:1 to 12:1. Whereas the compression ratio here is higher, 14:1 to 25:1. This is because the gasoline engines or the petrol engines use lower compression ratios to avoid fuel auto ignition. Say for example, that is what the doubt can be clarified here. If the same petrol and air mixture, if it is being compressed more than 12:1, if I compress it to 25:1, what happens? Without a spark plug itself, it will catch fire and it will burn. Because the petrol engines or petrol fuel is highly volatile in nature, this is what happens. Okay. Now in the petrol engine, less power is produced due to lower compression ratio. Is it clear? Less power is being produced due to the lower compression ratio. Obviously, because of the higher compression ratio, the higher power is being produced. It is only because higher compression ratio leads to higher thermal efficiencies and better fuel economics. Is that clear? Now, in the petrol engine is fitted with a spark plug, and in the fuel engine it is fitted with fuel injector used to glow plug method. That is the difference. In the petrol engine, what happens? It burns fuel that has a high volatility, whereas here it burns fuel that has got low volatility. Is it clear? Now in the petrol engine, there are used in light vehicles which requires less power, for example bike, scooter, jeep, cars, etc. Okay. Whereas these diesel engines are used in heavy vehicles which require high power, like buses, cars, trucks, locomotives, etc. And even it is not necessary that we cannot use a petrol engine for the heavy vehicles or diesel engine for the lower vehicles. Now you will get a diesel car also, you will get a petrol car also. Likewise, even we can go for petrol buses also, petrol engine buses. But what happens is the consumption becomes very heavy. Say for example, from place X to place Y, if you want to travel, it may take around 10 rupees for the charge. Now if you run it with the petrol, then you may have to pay around 80 rupees. That is the reason why economically it doesn't fit into that. That is the reason why the heavy vehicles don't go for petrol engine. One. Second point is, The petrol engines doesn't possess such a high power. It doesn't possess such a high power which is required to take that load. That is the reason why they don't go further. And then the fuel consumption in petrol engine is high. Fuel consumption in diesel engine is less. That is the reason why, my dear friends, you might have gone through it. If you take a petrol car and a diesel car, if you take the I-20 car of a petrol and I-20 car of a diesel, the I-20 car of a petrol has got a mileage of around 14 to 16. The same thing for 1 liter of petrol, it will run around 14 kilometers. If you imagine the same car with diesel, it runs more than 20 kilometers. It is only because the fuel consumption is less for a diesel engines compared to the fuel consumption for the petrol engines. The petrol engines are lighter in size, whereas the diesel engines are heavier in size. Petrol engine requires frequent overhauling, whereas overhauling of diesel engine is done after a long time. Lesser starting problems because it catches fire very early. Is a case for a petrol engines, whereas greater starting problems in a cold countries or a cold seasons or in a cold temperatures for diesel engines. Most of all the earlier Jeeps, now we have got all sophisticated engines for diesel also. Now I don't feel there will be a problem in starting. Okay, so these are all the few of the differences between petrol and a diesel engine. That is the reason why, because the difference in the compression ratio makes it, you cannot put a diesel into a petrol engine and run. Same way you cannot put petrol into the diesel engine and run. That is a major problem. Is it clear? Now we have got the other differences. It is nothing but 2-stroke and marine diesel engines, or 4-stroke marine diesel engine. It may be, in general, you can take it as a 2-stroke and 4-stroke engines. Now it has, the first and foremost point is, the 2-stroke engines makes one complete revolution of the crankshaft during the power strokes. As I have already told you, in 2 strokes what happens? From TDC to BDC it moves, from the BDC to TDC it will move. That means 2-stroke makes one power cycle. Whereas in a 4-stroke engines, TDC to BDC, BDC to TDC, TDC to BDC, once again BDC to TDC. So the 4 strokes makes one power stroke. Is it clear? So during this movement in the 2-stroke engine, it has a one complete revolution of crankshaft. It will do it in a power stroke. Whereas here it makes 2 revolutions of the crankshaft during one power stroke. Is it clear? It generates high torque. 2-stroke engines generate high torques when compared to the 4-stroke engines, whereas 4-stroke engines generates less torque. It has a larger ratio in terms of power to weight ratio. It has a lesser ratio in terms of power to weight ratio. It generates more smoke and show less efficiency. The efficiency of the 2-stroke engines are very less. That is the reason why we have absoluted, we have stopped using 2-stroke diesel engines. Is it clear? It generates less smoke, shows more efficiency in case of 4-stroke engines. A crankshaft to camshaft ratio is 1:1, whereas here the crankshaft to cam ratio is 1:2. That means it is a bit bulkier than 2-stroke engines. One centrally mounted exhaust valve, one basically mounted exhaust valve in uniflow scavenging, and exhaust valve is opened hydraulically and closed up by air spring. Whereas here the 2 exhaust valves are provided. Opening and closing of the exhaust valve is done by the push rods or the taplets. That is what we call it. Here it is something like ports are used in 2-stroke, whereas here the valves are used. Okay, so they are slow in speed engines. They are slow speed engines, whereas they are medium speed and high speed engines. That is one of the major reasons they use it. The combustion air comes from scavenge manifold via scavenge ports in liners. Whereas here in the 4-stroke engines, combustion air comes from scavenged manifold via inlet valve. The stuffing box is provided, where no stuffing box is being provided over here. They are cross-head engines. They are trunk piston engines. Piston rod is present in the piston rod will not be present, but we will have a connecting rod. Is it clear? Now no gudger pin is being used, and the gudger pin is being used to connect the connecting rod to the piston. Okay. Now the high thermal efficiency is being provided in 2-stroke engines, and less thermal efficiency is being achieved in 4-stroke engine. When you also talk about the overall efficiency of the 4-stroke engine is more compared to the overall efficiency of a 2-stroke engine. Constant pressure turbocharging system is used, whereas here the pulse turbocharging system is being used. Is it clear? And one more technical point which we have missed out here is a transfer port is present in the 2-stroke engine, whereas the transfer valve or a port is not being present in the 4-stroke engine. That is first point. And one more thing is the fresh charge will enter into the engine cylinder in the 4-stroke engine, whereas in the 2-stroke engine the fresh charge will enter into the crankcase. Is it clear? Crankcase will enter into. Is it clear? Now the engine cylinder will take the fresh fluid from the transport port in 2-stroke engine, whereas in the 4-stroke it takes from the inlet valve. Is it clear? Now since the simultaneous exhaust and inlet strokes takes place in 2-stroke engines, what happens? There is the chances of mixing the fresh charge with the exhaust smoke. These mixing possibilities are not present in the 4-stroke engines because of the valve operations. So obviously the efficiency of 2-stroke engines is less compared to the efficiency of the 4-stroke engines, because the quality of the charge that is it is going to be in the engine is of lesser quality or a diluted one, whereas in a 4-stroke engine the quality of the charge will be very high. Is it clear? That is why it burns it very clean. And 2-stroke engines makes more noise because of this compared to the 4-stroke engines. Okay, and even I have also told one more point, that is the scavenging process. Scavenging is nothing but the process of expelling out the hot burnt gases is called as a scavenging. Scavenging is an easy procedure and it takes place very smooth in 4-stroke engine compared to the 2-stroke engines. So these are all the different differences between the 2-stroke and 4-stroke engines. Okay, now let us go with other differences also. The cycle is completed in 4 strokes of the engine of the piston, whereas in 2-stroke engine the cycle is completed by the piston in 2 strokes of the piston. It has 1 power stroke in 2 revolutions, whereas it has 1 power stroke in 1 revolution of the crankshaft. Heavier flywheel is being used. This is a very important point. In a 4-stroke engine, heavier flywheel is being used, whereas in a 2-stroke engine the lighter the flywheel is being required. For the same power, heavier engine is required for the 4-stroke engine. For the same power, a lighter engine itself is sufficient enough. Okay, now the cooling, when it comes to the cooling and lubrication, lesser requirement of cooling and lubrication for the 4-stroke engines, whereas here a greater cooling and lubrication are required here. And more of what happens, the coolant because it is just takes a 4 strokes, the heat that has been generated in the engine or the heat is very less compared to the 2-stroke engine. That is the reason. And then it contains valves and valve mechanisms, so higher in cost. It has got ports, so cheaper in cost. But even the presence of ports has also got its own disadvantages. More volumetric and thermal efficiency, whereas the less volumetric emulations. Used in high efficiency motorcycles like cars, buses, trucks, aeroplanes, power generation. Whereas here it is used in mower, scooters, motorcycles, mopeds, ships and small boats. They go for the two-stroke engines. Let us go with one of the numericals which we have already discussed. Okay, it is. I'll show you with one or two examples. A 4-cylinder, 4-stroke petrol engine having 90 mm bore and 130 mm stroke develops 30 kilowatts of power while running at 1500 rpm and using a 20% rich mixture. The theoretical air-fuel ratio is 15:1. The calorific value of petrol is 46,000 kilojoules per kg. The volumetric efficiency measured at 15 degree, it is 15 degrees centigrade, and 760 mm of mercury as the standard temperature and pressure. The volumetric efficiency is given by 70% and mechanical efficiency is 90%. So find out indicated thermal efficiency, brake mean effective pressure BMEP, and brake thermal efficiency. I just will use a simple formula in order to find out this. He says it is a 4 number of cylinders. For one cylinder, the swept volume is nothing but pi d square by 4 into L, where d is nothing but the engine bore diameter and L is nothing but the stroke length. I will convert these things 90 mm into meter, that is 0.09 meters and 0.13 meters for the stroke length. So I will multiply with n, small n, so that it will give you the complete total swept volume in terms of meter cubes. So I will substitute as n into pi d square by 4 into n, which gives rise to 4 into pi into 0.09 square divided by 4 into 0.13, which will give you 3.3 into 10 to the power of minus 3 meter cubes of swept water. Now let us go. The volume of air drawn in the engine in the suction stroke is given by volumetric efficiency is equal to basically what happened, swept volume divided by volume of air drawn. So it is nothing but volume of air drawn is equal to swept volume, which we have already found out in the previous formula, 3.3 into 10 to the power of minus 3 into 0.07. Similarly, we just get it as 2.31 into 10 to the power of minus 3 meter cube. I will also find out the volume of flow rate of the 4-stroke engine, which is given by volume sucked during suction stroke into n divided by 2. Because it is a 4-stroke engine, I will take it as n divided by 2. If it is a 2-stroke engine, I would have taken only n. So volume sucked during suction stroke, it is nothing but 2.31 into 10 to the power of minus 3 into 1500 rpm divided by 2, which gives rise to 1.737 meter cubes per minute. We can also convert this into seconds by dividing it by 60, so that we will get it by meter cube per second. This volume flow rate is at a pressure of 760 mm of mercury. 760 mm of mercury is nothing but 1.013 bars. That can also be given it as 101.325 kilopascals at temperature 15 degrees centigrade, that is 298 degree kelvins. So the mass flow rate of air, MA, is given by PV by RT, where P is the pressure, V is the volume, it is we have found out, R is the standard one, 287, and temperature is 298 degree kelvins. After substituting this, we will get the mass flow rate of the air, that is 2.057 kgs of air that we are supplying for every 1 minute. And here also you can find it with respect to kgs per second by dividing it by 60, so that you will get it as 2.057 or something XYZ with respect to kgs per second. Next one is mass flow rate of fuel used is nothing but MA divided by 15. It is only because he has given the air fuel ratio. It is nothing but 15:1. So this leads to 0.137 kgs per minute. Using 20% rates, that means 120 by 100 will gives rise to mass flow rate as 0.164 kgs per minute. By dividing it by 60, I'll get it 2.74 into 10 power of minus 6 kgs per second. This will gives rise to the brake power. Brake power he has given it as 30 kilowatts and mechanical efficiency is equal to 90%. So the indicated power will be given by mechanical efficiency formula. Basically it is nothing but BP by IP. So BP is known and mechanical efficiency is known, so that I'll get the IP. Once you know this IP and BP, the difference will give you the frictional forces, which is nothing but 3.3 kilowatts. Now here, now I just find out the indicator thermal efficiency. MF into CV will give rise to mass flow rate, means what is the amount of fuel which is going for every second. If the engine is running, say for example your bike is running or if your car is running, what is the fuel, how much fuel it is consuming for every second or for every minute will be given it as mass flow rate. If you use a diesel, it is property is different. If you use a petrol, it is different. If you use a kerosene, it is different. That means every fuel will have its own the quality or the measurement. That is what we call it as property is called as a calorific value, that is denoted by C. It is 46,000 kilojoules per kg. So indicated thermal efficiency is given by IP by MF into CV. MF into CV, that product is nothing but amount of heat supply. So that will give rise to 26.4% of indicated thermal efficiency. Similarly, I will also find out the brake thermal efficiency, which is given by BP by MF into CV, which is equals to 30 divided by the same MF into CV will give rise to 23.8. Now even in here, the indicated thermal efficiency is greater than the brake thermal efficiency. And the last one, which he has asked us to find out, is the brake mean effective pressure. The BP is equal to N into PBM. PMB actually it is PMB, that is mean effective brake mean effective pressure into LAN into K divided by into 10 divided by 6 will give rise to kilowatts. Now here, my dear friends, the BP is being given in the problem itself, which is nothing but 30 kilowatts. Then N is nothing but the number of cylinders, and the BP which we have to find it out, and L is nothing but the stroke length in terms of meters, that will give rise to 0.13 meters. And then the area is nothing but 5d square by 4, where d is nothing but the bore diameter or inside the cylinder diameter. It is one and the same thing, don't get confused. And N is nothing but the speed, which is nothing but revolutions per minute, 1500 RPM. I will substitute as it is. And then the K. Now K is nothing but a constant, and this constant value is equal to 1 for 2-stroke engines, and this value is equal to 1 by 2 for 4-stroke engines. Now this is, in this problem he has given it very clearly that this is a 4-stroke engines. So since it is a 4-stroke engines, we will have 1 by 2, or we can also substitute as a 0.5 also. So K is equal to 1 by 2 will give rise to 10 divided by 60. After all calculating this, we will get 30 is equal to 4.135 PB, which yields to the mean brake mean effective pressure, which is equals to 7.25 bars. That is as per the problems. That is the solution for this. Okay. So few more examples I have given it in the material. You can go through it. We have done many problems, around 15 problems I have done it along with the answers. You can go one by one. Always we should remember the basic formulas of IP, BP, FP, indicated thermal efficiency, brake thermal efficiency, mean effective pressure. So these formulas should be confidently remembered. And one more thing is the swept volume or the volume of the cylinder should be taken. Some certain occasions what they will do it is, instead of giving the area and stroke length, what they will give it is the volume of the cylinder is equal to so and so. The volume is nothing but area into length. Correct. Even if I want to find out the swept volume, it is nothing but pi d square by 4 into L. So that itself is nothing but the volume of the cylinder. Since he has mentioned it as a 4 number of cylinders, we have multiplied with the 4. That's all.